All right, so recording is alive. So you guys are all here because you want to learn how to multiply radicals. Or maybe you don't want to learn multiplying radicals, but you are anyway because it's part of something that you need to do. So these are the rules we have about radicals. So you guys are having a fun conversation. I can see that. Have to learn. Yes, you have to learn this. For those, so you may be wondering who has to learn this. If you have to take pre-calc or you have to take calculus, you're going to have to learn this. So basically people in engineering and likely computer science. So the rest of you, this is just good practice for logical thinking, but you may not actually have to do this in your life. So there's probably going to be about half of you that are thinking, thank goodness, and the other half that are going, oh man. So a radical is like undoing an exponent. So we call something a root. The answer to a radical is called the root. So the nth root of a number is the number that when taken to an exponent equals that number. And if so, we write this as we've got the radical symbol, which is how you know the square root symbol, but we have a little n up on the upper left of a equals b. So a square root of 4 is 2. So 2 is the root of 4 because 2 squared gives you 4. So there are two rules for simplifying. If you're taking a radical where your index is the same as your exponent, so the index is the number outside of the radical symbol. If those are the same and you have an odd number underneath the exponent, your answer is just whatever the thing is. They cancel out. If you have an even, or if you have an odd index, it just cancels out. And just whatever number, if it's positive or negative underneath the exponent, doesn't matter. If you have an even index, you would have to take the absolute value because we can't like take the square root of a negative and get, it deals with imaginary numbers. And when we're simplifying radicals in this part, we're not dealing with complex numbers quite yet. So you don't have to worry about that. And then there are the product and quotient properties, and we're only going to be focusing on the product property because we are multiplying and the word product means multiply. So if you multiply radicals that have the same index, you can combine them into a single radical. And that's essentially what we are going to be doing here. So like I said, we're going to be using this product property. So when you're multiplying radicals, all of our known rules about multiplying still hold. This distributive rule still holds. FOIL still holds. You can multiply using a table. All of these things that we've done so far work even when there's radicals. So it's not like you're learning some new technique. You're just taking things you've already learned and applying it now to having radicals. And then there's a special thing where you have conjugates, and conjugates are the same thing, but with opposite signs. And when you multiply those together, your radicals basically cancel out. 9 plus 10 still equal 21. Maybe if you're in some other world, 9 plus 10 equals 21. We are still in our world where 9 plus 10 equals 19. We have not left a new world of math. We're not in a new world. We're still in the regular worlds of math. So we're going to just start off simple. And you may think it has square roots in it. It's not simple. But this is as simple as it gets for square roots. So we're just multiplying two radicals together here. We've got -2 times the square root of 6 times 4 times the square root of 3. So week 1, we learned about the different things about math. And one of the things we learned was the commutative property, which says that the order of multiplication doesn't matter. If you have a whole bunch of things multiplied together, you can put them in any order you want, basically. So what we're going to do is going to take the whole number parts and put them in front and then put the radical parts in the back. So we're just going to rearrange what we have here. So I have a number, I have a -2, and then I have a 4. And then I'm going to have my square root of 6, and then the square root of 3. So when you see a number in front of a square root, we assume that that is still multiplication. So this is all multiplied together. And so you multiply your whole number things together. So -2 times 4 is -8. And then you multiply your square roots together. So when you multiply square roots, you multiply what's inside the square root together. So we would have 6 times 3, which is 18, and then that's inside the square root. So we have -8 times the square root of 18. So you multiply the whole numbers, you multiply your radicals. Then you need to simplify the square root of 18. So there are 2 ways to do this, and I have a video where I go over this in much more detail. You can do what's called the prime factorization of 18. And so you have everything as a product of primes. You make a factor tree basically. And then anything that has an exponent of 2, you take the square root of, and then it simplifies. Or you just, if you know your square roots really well, you can split it up. Like that's what I would do here, because I know that 18 is 9 times 2, and I can take the square root of 9. So when they're small numbers, I don't do a product of primes. So I'm going to rewrite 18 as 9 times 2. So we've got the square root of 9 and the square root of 2. These are inside one square root. And we can split it back up so they're in outside 2 different square roots. So we are doing this specifically so we can simplify. And these are all multiplied together. And then you take the square root of 9, which is 3. So we have -8 times 3 times the square root of 2. And then you multiply your numbers together. So -8 times 3 is -24. And then we have times the square root of 2. And this is our final answer. So the process here, as you first combine things together, then you get a radical that you try to simplify by splitting it back up apart. And then that will give you whole number parts that you combine together. And then that gets you your final answer. So we would write our final answer as -24 square root of 2. Are there questions? I know it sounds like it's making sense now. The trick is when you do these on your own, try to repeat my voice in your head and see if, pretend I'm there, or everybody just needs to clone me so that I can be right next to you. Okay. Math in your head while sleeping. Sometimes I dream about math too. Get this to move on. There we go. Okay. So I'm going to pick I'm going to do just the one on the right. Because like I said, I think I have too many examples. So I'll just not do the one on the left. I'll do the one on the right. And then I'll leave the one on the left. I'll put the answer at the bottom when I share the PowerPoint. And then what you can do is try to do the one on the left and then see if you get that answer on the bottom. And if you don't, then you can email me, and then that would be a good way to kind of test, like, oh, does this make sense? So I'm going to do the one on the right because it's a fourth root, and square roots are usually easy enough, but once you start working with higher indexes, they tend to get a little harder. So we're going to do the same thing. We're going to take the number parts and multiply those together and put them in front. And then we're going to take the radical parts and put them together. So the number parts on the outside you multiply, but you can't also multiply it by what's inside the radical because that's kind of separated. So I can do the -4 times 3, which is a -12. And then I'm going to take my radical parts and I'm going to multiply the insides. So inside I can do the 12 times 4, which is 48, I think. I should double check that. just in case. Yeah, 48. So 12 times 4 is 48. And then when you multiply your exponents, or your things with the exponents, the m squared times m squared, you add the exponents. So 2 plus 2 is 4. So I've got -12 on the outside, and then the fourth root of 48m to the fourth. So m to the fourth, and then the fourth root, those can cancel out because the fourth root, the index is going to cancel out the exponent because they're the same. 48 does not cancel out though. We want to split 48 up as something we can take the fourth root up. Now, I don't have my fourth roots memorized. You guys are not going to have your fourth roots memorized. So this is where I do a factor tree to try to figure out how can I rewrite 48 so that it's something to have an exponent of 4, because I want it to be 4 because that's what our index is on the outside. So I know that 48 is 12 times 4 because I literally just did that to calculate 48 here. And 4 is 2 times 2. 12 is 4 times 3. And then I'm kind of running out of room here. 4 is 2 times 2. So I've got 1, 2, 3, 4 2s, and then a 3. So you're just kind of breaking down your numbers until you can't break them down anymore. So I'm going to rewrite this. I have my -12. I have my fourth root. And then I've got 1, 2, 3, 4 2. So it's going to be 2 to the fourth. And then I have a 3. And then I have my m to the fourth. And I need to make sure that all of that is inside my radical. So anything that has an exponent of 4, I can take the fourth root of. So I'm going to put those in front and kind of separate them out. So I'm going to have the fourth root of 2 to the 4. And then I can also do the fourth root of m to the 4. And then I have this leftover fourth root of 3. So the fourth root and the 4s, those cancel, then they're just multiplied together. So you're going to have -12 times 2 times m, because all of those exponents cancel with the fourth root. And then I have fourth root of 3. So now I've simplified inside the radical, and I've got these numbers on the outside I can multiply. So I can do -12 times 2, which is -24. Then I'm going to have my letter m, and then I'm going to have the fourth root of 3. And that is your answer. Now, I have seen, I think Alex does this sometimes. I think the textbook does this sometimes where they put the variable after the radical. I don't like to do that. I don't like to put things after the radical because it gets confusing on, is that supposed to be inside or outside? If it's in front of the radical, it's very clear that that's not inside the radical. So I put all of my stuff in front. But I have occasionally seen the radicals written in the back. I recommend putting them in the front. That also helps when you're in Alex, because then you don't accidentally put it inside when you don't want it on the inside. Because if you try to put in the back, I've seen people type it wrong accidentally because they don't like hit the arrow key enough to leave the radical symbol. So just anything that's not in the radical, put in the front, the rest of it goes in the back. Are there any questions? Wow, no questions. Okay. So moving on, distributive property. So now let's apply the distributive property. And you know what? Actually, I'm going to skip this one and do this one because this one has smaller numbers and it'll be a little bit easier. So we'll do this one. So the distributive property applies even when you have radicals. Now, when you've been doing the distributive property so far, I hope that you've gotten to the point where you can just do the multiplication in your head. Because, you know, you can just multiply the numbers and then add your exponents on the things with the letters. I don't recommend doing that once you throw in square roots, cube roots, that kind of thing, because it's very hard to do those in your head. I don't always, I mean, depending on what it is, sometimes I'll do it in my head, sometimes I won't. I don't recommend that you guys try to do the multiplication in your head. So we are going to actually write every single step because that will help you a lot. So distributive property is that thing on the outside times everything on the inside. So I'm going to literally write that down so you can see what you're actually multiplying. So we have -7 square root of a times 6 square root of a. And then I'm going to put a plus, and then we're going to multiply that by the next part, and that minus in there is going to go with it. So it's going to be a -7 square root of a times -4 square root of b. So you want to actually write what you're distributing. So that way you can see what you're doing, because it's harder to do in your head. So you can see that we've got basically what we just did, but now we've got two of them that we're working, because now we've got two sets of radicals being multiplied together. So just like our other examples, I'm going to put all the number parts first, and then I'm going to put the square root parts. I'm going to do this for both of them. So I'm just rewriting it so you can see what you're multiplying. And then I'm going to actually multiply the numbers. So -7 times 6 is -42. I had a brain fart. I'm like, that's not it, right? No, that's -42. And then when you have inside the square roots, a times a, that's a squared. So that's going to be the square root of a squared. Then I have a -7 times -4, which is +28. And then inside the square root, I'm going to have a times b. These are two different letters, so we don't have any exponents that we're adding together. So now we have -42, and then the square root of a, or the square root of a squared, that square root cancels out something squared. So that becomes -42a. And then we have 28 square root of ab, and we cannot simplify that because we don't have any exponents of 2 that we can cancel out. So our final answer contains a part without a radical and a part with a radical. We can't add these together because in order for them to be like terms, they both need to have radicals, and they have to have the same things inside the radicals. So these are considered two separate things. They are not like terms. Any questions? You guys were so chatty in the first 10 minutes, and now you're like, but I know, you know, it's a Monday night. I get it. Okay. Here's one where you want to do FOIL. So we've got 8 times the square root of 7 minus the square root of 5. And then the square root of 7 plus 3 times the square root of 5. So we're going to go through the FOIL process, and I'm going to write down each step what we're actually multiplying together so that you can keep track. So first, we're doing 8 square root of 7 times the square root of 7. So 8 square root of 7 times the square root of 7. Then outside, I'm going to put a plus. 8 times the square root of 7 times 3 times the square root of 5. Inside, so plus, I have a negative square root of 5 times a square root of 7. And then last terms, negative square root of 5 times 3 square root of 5. So you want to write down all of the actual, multiplication that you're doing. And then we're going to work each term doing the multiplication. So the first one, we have 8, and then there's no other number to multiply it. So it's just going to be 8 in front. And then inside the square root, you multiply 7 times 7, which is 49. Or I can write this as 7 squared. So you can see that it's going to kind of cancel out that exponent. Next, I do want you to get to the point where you can just do the 8 times 3. So that is 24. And then you multiply inside the square root 7 times 5, which is 35. Then I'm going to have plus a minus. So that's going to be minus. And I don't have any numbers, so I just have the square roots to multiply. 5 times 7 is 35. And if it helps, you can put a 1 there if you want to see a number out in front there. And then I have another minus here. And that minus square root of 5, you can think of that as a minus 1. So you're doing a negative 1 times 3, so that's negative 3. And then 5 times 5 is 25, or I could just write 5 squared right there. So we're going to move left to right. The square root of 7 squared, those cancel, and you're just left with 7. So this is going to be 8 times 7. Then I have plus 24 square root of 35, and 35 cannot be simplified because to get to 35, we did 5 times 7, and those are both primes. So that's not going to simplify. And I'm minus 1 times the square root of 35. And then I have minus 3 times 5 because the square root of 5 squared, those cancel. So I'm going to do my multiplication. We're following the order of operations here. So multiplication before we do any addition or subtraction. So 8 times 7 is 56 plus 24 square root of 35 minus 1 square root of 35. And then 3 times 5 is 15. So that's going to be minus 15. And now we're going to add our like terms. So the 56 and the minus 15 we can combine, which I'm going to use my calculator for. 56 minus 15 is 41. So that's going to give us 41. And then the parts with the square root you can combine because they are like terms. They both are square root of 35. So when you combine those, you take the numbers in front and you do the math. So that would be 24 minus 1, which is 23. So we get 23 times the square root of 35. And then we cannot simplify that because square root of 35 doesn't simplify. So that is your final answer. So, okay, so in the reading, the constant goes to the front. Why is that? We put the constant in front because it's easier to read it that way. Because we're so used to, it's sort of like when you have your variable, you have your number in front of the variable. So when you're adding like terms, if you pretend that your square root parts are variables, it makes sense that the numbers in front are the ones that you're going to actually combine. Because seeing something like 24 square root of 35, 24 square root of 35 minus 1 square root of 35 is essentially the same thing as if you saw 24x minus 1x. When you simplify, you get 23x. But in this case, x is just the square root. So the constant is in front because we're using the same rules that we've used with variables, where if you have a constant that goes in the front, everything else is in the back. So you can think of that square root of 35 as being like a letter. And if it makes it easier for you, you could kind of rewrite it as a letter and then put it back in when you're done, if it makes things easier for you to do that. Another reason why we put the constant is in front, and I mentioned this earlier, is to make it clear what is inside the square root and what is outside. Because if we wrote it the other way and we wrote square root of 35, 24, if you're not careful, you might be wondering, well, is that whole thing inside the square root? Is just the 2 inside the square root? Or maybe it wasn't 35, maybe it's really 3 inside the square root. So it kind of gets confusing, especially when you're writing by like on paper, you know, with your hand. If you're not careful with that line, you may be confused about what's inside and what's outside. But if we put the 24 in front, it's very clear what's inside and what's outside. Oh, okay, Georgia, I misunderstood your question. I was thinking about the wrong constant. I was thinking the coefficient constant, but you're saying, okay, constant goes to the front. Why? Okay. So your question is actually about the 41. Why do we have it as 41 plus 23 square root of 35 versus 23 plus 23 square root of 35 plus 41? Because if you have like the square root of 35 like a variable, you would have the variable part first. So I see, yes, that's how we normally do it. This is actually for the same reason of confusion, because if you're not careful with how you write your square root, you might think that the plus 45 is inside there, or plus 41. You know, if you're kind of messy with how you write this. So by putting the 41 at front, it just kind of eliminates that confusion where you're not sure what's inside the square root and what isn't. When it's typed up, this confusion doesn't really occur, but it can happen on paper. So that's why when we have things with square roots, we just always put the square root in the back. And then the constant, just the whole number part in front. And we do the same thing with complex numbers too, where we put the complex number in the back and then the whole number part in the front. So that's the one spot where square roots and imaginary numbers are different from working with variables. They have the same rules as variables when you're multiplying and everything, but when we write our final answer, they're slightly different where we put that number part in front without the rest of the joke. Does that make sense? Okay. And both are completely correct. So if you put it in the other way around in Alex, it would mark it correct. If it doesn't, that would be something that I would override manually because they are the same thing. They mean the same thing. So I just always put the number in front because it's, you know, less likely to get confusing that way. There are other questions. Alex doesn't accept the other way. Good to know. Okay. So if you do it the wrong way on the quiz, I will, for, you know, if your answer is equivalent on the quiz, I do give points for that. And if it's just in the other way and they mark it wrong. On the homework, you just have to make sure you put it in the right way because you do have unlimited attempts. But on the quiz, I would definitely correct that for you. And I've done that before where people have put in the correct answer, but it wasn't in the right form that Alex wanted it. And I give points back for that. Yeah. I imagine that Alex is that way just because it's a lot easier for it to be coded that way. You know, because if you think on the back end, it's all computer code. And the more possibilities you allow, the more complicated the code gets. So I feel like they probably just made a decision that we're always going to do it this way. And most people will enter it in that way. And so just, you know, it is good to know that Alex wants it a specific way. So that way you can just be aware of that. But, you know, on paper, it doesn't matter. So let's see, let's do this one. Okay. So here's one where we cannot do FOIL because we have 2 things times 3 things. So this is where I would use the table method. I don't like to use arrows when I have more than 2 things that I'm multiplying because you just get lost among the arrows. So I use the table method for this. And when you're using the table method, it's a little bit harder to do with square roots, but you can do it. So we've got the square root of p plus 2 times the square root of q. And then we have 8 plus the square root of p minus the square root of q. So it doesn't matter which one is horizontal, which one's vertical when you make the table. I tend to make my longest part the horizontal part. So that way it takes up less room, you know, because on my piece of paper, there's more room. It just kind of fills up the room. You know, it seems like a more efficient use of the space on paper. So I would put going across the 8, the 3 square root of p, and then the minus square root of q. And then going down, I'm going to put the other part, the square root of p, and then 2 times the square root of q. And you're going to want to leave yourself enough space because you're going to be having like whole numbers and all that kind of stuff. It's, you know, it's not like you're just multiplying numbers. So I always work going across first row, first column, second column, third column. So I always deal with the first row first. So we would have the square root of p times 8. So the 8 goes in front, the square root of p goes in the back because you don't have anything really to multiply. They just kind of hang out together. The next one, we have square root of p times 3 times the square root of p. So there's no number to multiply the 3 by. And then the square roots you multiply, p times p is p squared. So I'm going to have the square root of p squared. Then the next one, I have a positive times a negative. So my answer is going to be negative. And this is going to be square root of p times q because they're not the same. So they're just going to be kind of next to each other inside the square root. Then I'm going to move bottom. So we've got 2 square root of q times 8. So you do 2 times 8, which is 16. and then the square root of q. Then I have 2 square root of q times 3 square root of p. So we're going to do 2 times 3, which is 6. And then the order here, it doesn't matter. I could put q times p, but I'm going to just try to keep it in the same order as my other one. So that's going to be p times q. And then I have 2 times the square root of q times negative square root of q. So 2 times a negative is a negative 2. And then I have my square roots, and then q times q is q squared. So we have 6 things that we've just multiplied here. And so now you want to write them all out. And it doesn't really matter what order we write them, because we can rearrange it after we combine like terms and all that kind of stuff. So I've got 8 times the square root of p plus 3 times the square root of p squared minus 1 times the square root of pq plus 16 times the square root of q plus 6 times the square root of pq, and then minus 2 times the square root of q squared. So the p squared inside the square root cancels out, and that's just a 3p. The q squared cancels out, and that's a q, so it's going to be a minus 2q. And then the only like terms that you see here is this negative 1 square root of pq and the plus 6 square root of pq. So you would have negative 1 plus 6, which is 5 square root of pq. And it doesn't matter where you put it, so I'm going to just put it right here. And then I'm going to just copy down everything else, because you're kind of looking at where do you have things that match. We already added that. So then I have this plus 16 square root of q. So the square root of p is not like terms with the square root of q, because they have different letters inside there. And those are not like terms with the square root of pq, because they don't have both of them inside there. So we have these, we're going to have a lot of things here that just looks gross. So the order, I mean, it doesn't matter what order you put these, but we usually put the non-square root stuff in front, and we usually put it in alphabetical order. So that would be the 3p first, and then the minus 2q. And then the stuff with the square roots, it really doesn't matter what order. So I'm going to just go from left to right. Plus 8 times the square root of p plus 16 times the square root of q. Whoops. And then plus 5 times the square root of pq. And it does not simplify. That's your answer, and it looks gross. I have no idea what order Alex would want something like that in, because there's not really a convention. But I can tell you that something this complicated is not on your quiz. So don't worry. You don't have to do something this big on the quiz. This is just kind of to practice your rules, your organizing, you know. And for those of you that do have to go on to calculus, the reason why you need to know how to do this is because there's this thing that you do in calculus called derivatives and integrals. And they are easier to do when you have things multiplied out than when you have them like actually written as multiplication. So it's actually easier to do once you multiply, because otherwise you have to use different rules. So that's why knowing how to do this would be very helpful, because it will make your life easier in calculus. Any questions? You feel like you should get a new major. If you're going to engineering, the good news is that once you get past calculus, it's assumed that you can use technology to do things like this. So it's more of understanding the calculus and being able to go through here, and then you can, apply it. And yes, for those of you that are not going into engineering, you still have to learn this because this is the typical college algebra. Yeah, once you get past this class, you'll be okay. You can do it. Yep. And don't, just it's just something that this is what's required. I don't know if this is going to change in the future, but it's like it doesn't matter what college you go to, they're going to require college algebra. That's just the way it is. So last week I talked about these special cases of multiplying where you have, something squared and then you're multiplying, you actually want to do the FOIL, and I talked about the difference of squares and everything. So now we're applying this to square roots. So I don't know how many of you remember what the shortcut is for multiplying something in this format. Yeah, so yeah, I would definitely separate it out. Yeah, the shortcut is like, squaring these things squared, but you can separate it out, write it twice to do FOIL. As I suspected, I didn't think anybody would remember the shortcut because I said that this was the less important shortcut to remember. And it's true, it is the less important shortcut to remember. So if you see something squared, write it twice, and then we're going to go through the FOIL process. But the nice thing is that this is not going to be as complicated as the other one we did. Okay, so Shannon's on her way. She's on her way, not quite there yet. Darnell wants to know what just happened. So I just literally wrote what we had twice because it has an exponent of 2. So we have in parentheses square root of 5a minus the square root of 3b, and then it's got a 2, so I just wrote that twice. So I haven't done any magic yet. I'm just rewriting it. So once you've done that, you want to FOIL. So we're going to take our square root of 5a times the square root of 5a. So remember I said that you're going to want to write that out, or you can do that multiplication in your head. You get 25a squared. So a times a gets you a squared. So otherwise you can literally write that down. It could be very confusing when you see all these things. And I definitely recommend writing down what you're doing for these middle terms. So we've got the square root of 5a times minus square root 3b. Then inside, minus square root 3b times square root 5a. And then the last terms, and I'm going to just write this out. So we have a negative times a negative, which is a positive. Or you can literally write minus square root of 3b times minus square root of 3b and leave the negatives there and then make it a positive. So when you do the actual multiplication here, so we have our 25, which is 5 squared a squared. So I'm just going to write it that way. Inside, so that negative, we got a positive times a negative, so it's going to be a minus, and then you're going to multiply inside the square roots. So 5 times 3 is 15, and then we have a times b. Now 5 and 3 are both prime numbers, so we don't have to simplify the square root of 15. Because it would just simplify to 3 times 5, and that's as far as it goes. So I'm just taking, I got the plus outside the square root times the minus outside the other square root. That gave me a minus. And then I took my 5 times 3. And then I have an a and a b, so I just put them together. And this is all inside the square root. Then I have the same thing here. So I've got a minus, and then inside my square roots, 3 times 5 is 15. And then it's b times a, but you can write that as a times b to kind of match them up there. And then I've got a negative times a negative, which is a positive. 3b times 3b. So 3 times 3 is 9, or you can write as 3 squared and b squared. So, are there any questions with where I am right now? Okay, so we went back to 5 squared because you can see then that when you take the square root, it's going to become a 5. You can leave it as 25 and just know that the square root of 25 is 5. But I like to write it as the exponent version so you can see the rule applied. And you can see that you're using the same rule on the numbers as you are on the variables. But leaving it as 25 is completely fine. Yes, and you can basically shortcut that. So you don't have to do that step. This is, you know, it depends on where you're at with your understanding. You can shortcut some of these steps. So when we take the square root, that becomes a 5a because they both have exponents of 2, so the square root cancels out the exponent. And these are both 1s in front of here, so the minus, they both have a -1, so when you combine those, that becomes -2 square root of 15ab. So you're adding them together, a -1 plus a -1 becomes a -2. And then we have the square root of 3 squared b squared. So the squares all cancel and you end up with 3b. So we end up with 3 terms here. And we put our 5a and 3b in front. So those are the parts without the radicals, and we put them in alphabetical order. And then I have a -2 times the square root of 15ab. So we lost the square root on the 3 squared b squared because it cancels out the square. So that square root cancels out the 2 that's on the 3, and it cancels out the 2 that's on the b. And then they just become 3b. Alternatively, that square root of 3b times the square root of 3b, if you actually multiply, that's 9b squared. So the square root of 9 is 3, and the square root of a b squared is b. Yes, Georgia, perfect squares. Aha! So yes, if it's not clear to you, you can write a 2 there to remind yourself. Square root cancels out the square, so they cancel out. The index is 2. So it's completely fine if you want to write a 2 on all of these. If that's what you need to do, whatever you need to do to make to have this stick in your head, you can do. Georgia, don't say you're slow. You remember the terminology. You remembered the exact word for that. You remember the index. You've got it. So yeah, the question is, how would we show this all this work and do this on, you know, like the quiz and have enough time? So the week 3 quiz is not a quiz where people tend to run out of time on. So that is not one where I've seen people run out of time on. And you do not have to do a FOIL one like this on the quiz. So on the quiz, what you would be seeing is something like what we started at the beginning. So because those are quicker. So something like what we did here is not going to be on the quiz, but you do need to know it if you have to move on. So hopefully that makes you feel better, is that you don't have to FOIL these things with square roots on the quiz. Because yes, it does take a while. There are other questions. Yeah, it's totally fine if you rewrite your work after the quiz to make it neater. That's I have no problem with that. Just make sure you don't change your answers. But like I said, people do not run out of time on this quiz usually. So it's not one that I am concerned about. Okay, if you used every second on the previous 2 quizzes, you might want to do more practice to get faster or put a little timer or something on. But some of the answers, I just had it opened up. I just put it away. I don't know why I did that. Some of the questions of the week through quiz are not too bad. Like question 4 is pretty fast. Question 9 is not too bad. Question 10 might take a while, so you might want to do that one first. But as long as you can factor, it shouldn't be too bad. Okay. For in general. So as long as you, as in you guys, the class, can factor, you guys should be okay. So this is going to be the last one that I do here, because I only have enough time for one more. This is special. These are conjugates because they are the same thing, but with different signs. So we talked about this last week. That this will become a difference of squares when you multiply it out. So this is one of the special factors, the special multiplications that we talked about last week, where when you multiply it, it's just the first thing squared minus the last thing squared. But with square roots, you may not remember that and it may look confusing. So we will go through FOIL. So you're going to do 4 square root of 7 times 4 square root of 7. And then our outside terms. So I have a 4 square root of 7 times, and it's going to be a minus 5 square root of 3. Inside. 5 square root of 3 times 4 square root of 7. And then 5 square root of 3 times minus 5 square root of 3. So going from left to right, I'm going to multiply 4 times 4, which is 16. And then 7 times 7 is 49. I'm going to just write that as 7 squared because there's literally 2 7s are multiplied together. Then we have 4 times negative 5, which is a negative 20. And then 7 times 3 is 21. And 7 and 3 are prime numbers, so I don't need to simplify there. Then I have 5 times 4, which is 20. And again, 3 times 7 is 21. And then 5 times -5 is a -25. And then the square roots, 3 times 3 is 9, or 3 squared. So now we're going to simplify again. We're going to move left to right. So that's 16 times square root of 7 squared. The square root and the square cancel, so that's just 7. And notice what's special here about the conjugates is that the inside terms cancel out. -20 times the square root of 21 plus 20 times the square root of 20, so, or 21. So -20 plus 20 is 0. And then you have the square root of 21. So 0 times the square root of 21 is still 0. So those just cancel out. They just equal 0. So you don't need to write it. And then here I have a -25, and then the square root of 3 squared is 3. So my whole square root part disappears. And now we're just going to multiply our numbers. So I've got 16 times 7. So that is 112. Minus, and then 25 times 3, which is 75. So we get -75. And then you just do 112 minus 75. We get 37. I moved my -75 to be close to the 112 because I just thought it looked weird if I put it all the way back here. Because that part is, yeah, is 0. So it's like it almost looks like at that point you've got two different things, but they're not. So it's just -75 there. So conjugates are nice because the square root part disappears completely and you're left with just a single number. Are there any questions? Yes, you can still pass as long as you do the work and turn stuff in. So just keep pushing forward. Don't give up. And like I said, this particular type of problem, this is not going to be on your quiz. Okay, well, I don't see any actual questions.